All right, chapter 2 from our physics book, the night book, is problem number 43. It reads, a football is kicked straight up into the air and it hits the ground 5.2 seconds later. What was the greatest height reached by the ball, assumed as kicked from ground level, and with what speed did it leave the kicker's foot? So the total time in flight was 5.2 seconds. So if we think about if you kick a ball straight up, it goes up, and then it should come back down. Well, we know vertical motion that what happens going up is symmetrical on the way back down. So if it takes 5.2 seconds total, that means to go up it's 2.6 seconds, and it is 2.6 seconds to come back down. So we're going to use that information to help us solve the problem. So in part A, they would like to know what is the maximum height that it reaches. Okay, so to do that, we're going to use that information of it traveling 2.6 seconds on the way up and on the way down to help us solve that problem. And what we're going to do is instead of looking at it on the way up, we're going to look at it on the way down, which again, we can do that because they're symmetrical. And knowing that, right, knowing that information, using that bit of information, we can say that the speed at the top is equal to 0 meters per second, which it is. So that's how we're going to solve this problem. So we're going to go with the second kinematic equation of y equals y sub o plus v sub o y t plus 1/2 g t squared, where the initial height is going to be 0. The height at the top, we're going to call the initial is equal to 0. So we're just left then with 1/2, -10, and 2.6 squared. And we find that the distance from the top to the bottom is going to be 33.8 meters, which then also means that it traveled from the bottom to the top 33.8 meters. Part B then asks, what was the initial speed that it was kicked at? So we can split it up again, and now instead of looking at it on the way down, we're going to look at it the way top. So if we look at it on the way to the top, when it gets to the top, its speed is going to be 0, and this time we'll call it v sub f, and down here will be v sub o. So using that bit of information, we can go with v sub f equals v sub o plus gt, which is the first kinematic equation. We know at the top it's going to be traveling at 0 meters per second because it's about to come down. And that's going to be equal to v sub o plus -10 times 2.6. So we find that in order for the ball to be in the air for 5.2 seconds, 2.6 up, 2.6 down, and traveling at a height of 33.8 meters, we need to kick the ball with a speed of 26 meters per second. So there you go. There's problem number 43 from chapter 2.